Okay, we've covered stoichiometry, so now we're going to go to one of the next steps. Okay, next step is using what's called limiting reactants. Okay, limiting reactants means you're combining two things together, and it's going to make a product, but ultimately one of those reactants is going to run out. Well, as soon as that reactant's gone, the reaction stops, and we can't make any more products. So we'll have a trick to figure, okay, which one of these is going to run out first, because that's going to limit how much of our product we get to make. Okay, limiting reactant. So if we're going to go through, and basically it follows the same process as stoich. First step is always to have a balanced equation. So I'm going to go ahead and run through the assumption that you can create a balanced equation at this point. So calcium phosphate reacts with hydrogen nitrate. And if that looks familiar, it's also known as nitric acid. In this case, I told you what it's making. I didn't have to. Calcium nitrate. So it's in parentheses because I have to have two of them. On this one, I didn't have to have parentheses. No, I've got it now, so it won't erase. Okay. Didn't have to have it because I don't have to show I have multiple of those. And now I've got hydrogen and phosphate are the only ones left. And phosphate's a -3, hydrogen's +1. So cross them down. H3PO4. If you look, that's otherwise known as phosphoric acid. Next piece is now I got to say, okay, I've got my equation, but I need a balanced equation. Always need a balanced equation. Oops. Yeah, I don't know. I don't need to be on the screen. There we go. Okay, so I'm going to write in regular pencil right now. I've got 3 CAs, 1 CA. What goes in must come out. So 3 go in, 3 have to come out. Now I've got 3 times 2, 6 nitrates coming out. That means you have to have 6 going in. Right now there's 1. So put a 6 in front. 6 hydrogens are going in. Only 2 come out, or excuse me, only 3 come out. So I've got to multiply by 2. 2 times 3 is 6 to match that. Now I have 2 phosphates coming out, and I have 2 phosphates going in. So my equation is now balanced. Now here's the reason. I'm looking for calcium nitrate. I'm looking for this. It gives me a mass of calcium phosphate. It also gives me a mass of hydrogen nitrate. I can only make so much of this. And that's because as soon as one of these runs out, the reaction stops. And that means I can't make any more product. We have to go through and figure, okay, which one is it? So what we do basically is we run 2 separate stoich problems. Yeah. So with that, I'm going to go ahead and start first of all with the calcium phosphate. So I'm going to be going from calcium phosphate, calcium nitrate. I've been given a value. And at this point, once again, we are running a straight stoich problem. And in a prior video, we got the molecular mass of calcium phosphate being 310, with that 0 being real. And whenever we have the molecular mass of a substance, then we automatically have 1 mole of that substance. And dimensional analysis is how we're going to get rid of things we don't want. I'm in moles of calcium phosphate. I'm here. I want to get to this. And if we look, I need to get rid of this, dimensional analysis. And the only thing I can do to change substance is a mole-to-mole ratio. So it takes 1 mole of this to create 3 moles of this. And that's why we needed that balanced equation. That's going to help us with the law of conservation of mass. Okay, so I could do that. Now, I could stop right here and get a mole value of calcium nitrate. If I did the same thing down here, actually, let's go ahead and do that while I'm talking about it. This time we're going to go hydrogen nitrate to calcium nitrate. I'm going to finish this problem in a little while, so I'm leaving it blank. We're doing the same process. Okay, so 48 plus 14 plus 1.01. Okay, 63.01 goes into hundreds, tenths. So if you can do that, that's great. If you can't, use one of the forms I gave you or scratch it on the paper. Okay, if I get molecular mass of hydrogen nitrate in one spot, that's 1 mole of hydrogen nitrate. Grams are gone. I'm in moles of this, but I want this. And we see that the ratio is a 6 to 3 this time. So 6 moles of HNO3 to 3 moles of CaA3, CaNO3, 2. So with that, once again, both these are now in moles of calcium nitrate. So I'm converting both these substances. If I had just asked you, or the AP test says, which one is the limiting reactant? I actually could stop at this point. All I would need to do is convert these, answer these, so it's moles of calcium nitrate. Whichever one of these ran out first is going to make the smaller amount of calcium nitrate. It's the limiting reactant. Okay, so I just, if it said, hey, which one's my limiting reactant? I just take it this far and then solve it. Smallest amount is what it is. But in this case, I said, okay, grams. So I've got to go one more step. And with that, I have to have the molecular mass of calcium nitrate, and I don't have that. Okay, and with that, 164.1. Oops, not paying attention. Sorry, trying to go fast. I've got moles dimensional analysis. I have to have it down here to get rid of it. Up here is the molecular mass of it. And same thing down here because I'm going the same substance. And one thing you'll find out about limiting reactants problems, they take up quite a bit of space. Because that's the work right there. Okay, those are two separate problems. And I'm still not done. I still have to have a solution for them. And I'm going to make you sit there and watch me. Okay, I always write down the calculator answer and then just adjust it for SIGDIGs. So I've got 3 here, underline 0, that means I've shown it as real. Mole ratios, those are infinites, 4 here. So my answer cuts at 3 digits. One spot to the right, it can round, that means it rounds that up. So in this case, what this tells me is if I were to use up all 34.5 grams of calcium phosphate, I'm going to make 54.8 grams of calcium nitrate. That's just saying if I did that, a straight stroke problem. Okay. But because I've got a limitation on my other substance, it's not in excess, I've got to go to the next step. And let me show you how I actually do these in the calculator. I multiply everything together on the top. Times 1, times 3, times 164.1. And then I hit equals. All I've done so far is that top. But I'm not clearing this. I'm now going to go onto the bottom. And everything on the bottom, we divide by. Okay. So I'm just doing that. I just multiplied straight across, hit equals, then divide by each thing on the bottom. And with that, calculator spits out 173.217. I usually do 5 or 6 digits. And 4 digits, 3 digits, 4 digits. I get 3, the smallest one. So what that means is if I would have just started with the hydrogen nitrate and used up all of that, I'd be able to make 173 grams of calcium nitrate. But I reacted it with 34.5 grams of the calcium phosphate. As these two react, ultimately one of them runs out first. And as soon as it does, we stop making product. So we have to look at the end values for the products. And whichever one is the smallest value, that means that reactant was the limiting reactant. Because as soon as it's gone, it limited how much product was made. I don't get to make this, okay, because I only used up this. If I wanted to find out how much of the excess reactant, this is what this one's called, remains, I start with this value. And I'm not asking for that, but if I did, I could just do this. If I converted that into grams of hydrogen, I wrote calcium. If I were to convert from grams of this to grams of this, it's going to tell me how much of this I actually used when I used up all of this. Yeah. Knowing that, I knew how much I started with. If I subtract out this value, it tells me how many grams I have left over. Okay. That's a limiting reactant problem. Remember, if you just want to find the limiting reactant, you can stop at moles. And whichever one made the smallest value is going to be your limiting. And because I multiplied them both by the same molecular mass, it's not going to change anything. This is only if it tells me, hey, what amount of product do you actually get to make? Well, this is what I actually get to make. I don't have enough stuff, both reactants, to make this. I can only make that because that's my limiting reactant. That's a limiting reactant problem. And they all play out like that. Okay, we're going to cover the molarity one in a minute, but I want to get you guys through that. So once again, I have, and I will post this, limiting reactants is step by step. And it goes through the piece. And I even show you how to get the limit or the excess reactant. I've got some examples we work through and some more, and I will have the key posted that if you ask for it. Easy enough. So that's going to be there. Hopefully that makes sense. If not, we can zoom and talk about it.